What's up, CoderByte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today we're going to be starting a brand new sub-mini series situation all about merge intervals. That's right. You know all those problems where it's like, here are all the times where people have meetings. Give me the times where no one has meetings. And the answer is never. Everyone always has meetings. No, I'm just kidding, but you know what I'm talking about. If you don't, please keep watching because we're going to go over it all in a second. And yeah, I hope everyone's been good. Let's get into this week's problem. Okay, so what are merge intervals and how are we going to recognize them in the wild? This pattern is all about efficient techniques to deal with overlapping intervals. Often in these sorts of problems, we're asked to find overlapping intervals or to merge intervals if they overlap. Given two intervals, that's a typo, but again, you guys know my feeling about typos. I leave them in. Given two intervals, A and B, there will be 6 different ways the two intervals can relate to each other. Understanding this will help us understand all the possible scenarios for our problems. So basically, if there are two intervals that you're comparing, let's say an interval that like I'm at 2 to 4, and then there's another interval at 3 to 7, right? Those are two intervals. There are only 6 ways that those intervals could possibly interact with each other. So the first way, A and B. A does not overlap B, right? A and B do not overlap. A comes first. What's our second option here? B and A. B and A and B do not overlap, but B comes first. So this would be a second scenario, depending on the problem. Third scenario, A and B, they do overlap. A and B overlap and B ends after A. So you can see here, A and B overlap, but B starts before A ends and B ends after A ends. Hopefully everything I just said is true, but whatever, someone can check me. Okay, fourth, B and A still overlap, A and B overlap, A ends after B. So you can see here, B starts first and then A ends last. 5, A completely overwhelms B, A completely overlaps B, and then finally 6, B completely overlaps A. So those are 6 scenarios. If you have two intervals, those are the only ways they can ever interact. And then from here, depending on the problem, we can narrow it down to actual scenarios we're going to be coming across and deal with them accordingly. Essentially, we're going to be coming up with some rules for how to merge these intervals based on which scenario they fall in these 6, or in sometimes less than 6 if we can somehow narrow it down and like knock some of these scenarios out if they're never going to happen. Okay, so what's our problem this week? What isn't our problem this week? No, I'm just kidding. Given a list of intervals, merge all the overlapping intervals to produce a list that has only mutually exclusive intervals. So this is a classic merge intervals problem. It's basically the most basic of the merge intervals problems, but we're going to have a list of intervals. So let's look at an example. So here we have some intervals. It's not necessarily time-based, right? It's just numbers in this case. So we have an interval 1, 4, we have an interval 2, 5, we have an interval 7, 9. And our goal is to somehow return the only mutually exclusive intervals, and we can merge all of the overlapping intervals. So 1 and 4 and 2 and 5 clearly overlap. So we can merge those and take the earlier of the two, which is 1, and the later of the two, which is 5, and merge them to 1 and 5. And then 7 and 9 doesn't overlap with either of them. So we can't merge those. We can keep that separate. So that's kind of our goal for this week's problem. Let's look at a visualization really quick of what these intervals kind of look like outside of numbers and code. So here we have our number line, which is 1 to 10. Again, often these problems have to do with time, but often they don't, and it doesn't really matter. It doesn't change anything. So we have our first interval, which is 1 to 4. We have our second interval, which is 2 to 5. And when it's shown like this, you really see that there is an overlap here. And finally, we have that third interval, which is 7 to 9. And here is our merged result. So we have 1 and 4, which have merged into 2 and 5. And so we get 1 and 5, and then we get 7 and 9 just carries over. Okay, so that's the problem. What is our approach here? So again, remember those scenarios that I talked about, that there's always only going to be those 6 whenever you're comparing just two intervals. So the first thing we're going to do is we're going to sort the intervals by start time. And this accomplishes a couple things. I think it's easier to reason about, obviously, but also we kind of knock out some of those scenarios. So if we go to the previous slide here, if we sort by start time, meaning the first one will always be A and the second one will always be B, and A is always going to have a start time earlier than B, we can kind of knock out this scenario 2 and this scenario 4, in addition to actually kind of like this scenario 6 kind of becomes scenario 5 because we're always calling the thing that starts first A. And we just sort our intervals that way. And that way we can kind of narrow down our test cases in our code for what's actually going to be happening. If we reduce our scenarios such that this A dot start is always less than or equal to B dot start, we're actually only left with 4 scenarios. So we've now reduced the possibilities that we could possibly have with those 2 intervals being compared. So the first scenario is that A and B don't overlap, right? A comes first. Second scenario is A and B overlap, B ends after A. The third scenario is A completely overlaps B, right? B is somewhere smack in the middle of A. And finally, we have one more case where B fully overlaps A, but both have the same start time. So in our last slide where we were looking at those 6 scenarios, we didn't quite have this. We didn't have A and B lining up like this. This is essentially the scenario that B completely overlaps A. But in this case, because we've sorted them, and whatever interval comes first is always going to be A, the only way we could actually get this is if A and B have the same exact start time. So that's kind of how we narrow it down from those 6 to these 4. And essentially, this is going to translate directly into how we interact with these intervals in code. So we're going to basically, plot, what is that called? Spoiler alert. I'm going to tell you how to solve this. Essentially, we're going to have a giant, looping, dropping my fidget spinners. Today is just one of those days. Essentially, we're going to have each of these scenarios is going to map to a specific place in the code where we are, it does fall into one of these scenarios. What do we do now? So what do we do now? That's the question. So in scenarios B, C, and D will merge, right? All of those somehow have overlapping intervals, so we have to merge them some way according to different rules, depending on which scenario it falls into. A and B, in that first scenario, where they don't overlap, we don't merge. So that's a case, but it's not actually going to result in a merge. We're going to take both of those intervals, again, because they don't overlap. So let's look at what this becomes. So in this case, in case B, we take A dot start, obviously, because A is always going to be like the earliest. And if anything, B is going to be the same earliest, so we can just still take A. So we're always going to take the start of A. And we're going to take B dot end, right? Because B ends after A. In scenario C, we are going to take A dot start again, and we're going to take A dot end because A completely overlaps B. And finally, in that D scenario, we're going to take A dot start again, like we're going to do that each time because we've sorted this intervals array. And we're going to take B dot end because B fully overlaps A, even though they both have the same start time. So these are further kind of reduced our 3 merge scenarios, whereas that first one, we're not merging at all, right? So how can we sum this up in like a code-like, pseudocode-like kind of rule here? So what's happening? We always say A dot start, so we know that that's going to be part of our rule. And then which end do we take? We always are going to take, right, the larger end. Simply, between the A end and the B end. We're just always going to take the larger one. And we're always going to take the start of A. And that's our whole rule, right? If A overlaps B, aka B dot start is less than or equal to A dot end. So B start is always before the end of A, which means A is not what we're talking about here, right? We need to merge them into a new interval C, such that C dot start is always equal to A dot start. We already said that because we've sorted this array. And the C dot end is equal to the maximum of the A dot end and the B dot end. And that's the whole rule. It's pretty simple. Outside of this, I think mostly what we're going to be doing is like figuring out how to do this in code. Another little spoiler alert here, we're going to be using a stack because we're always going to want to be merging the next interval with the previous interval we just had, because we're not only comparing two intervals, we're comparing all of the intervals. So we're actually always comparing whatever interval we just saw to the next interval we're about to see. So those are the A and B, but you'll see when we get there. So we pull off the stack as our A, and then we pull from that sorted array for our B. If nothing I said makes sense, don't worry, you'll see it in code. But that's the whole algorithm. Again, this is pretty bare bones. This is number 1 of 3 parts in this mini series. And I'd say this is like a bare bones, easy merge intervals problem. So without further ado, let's code this. Okay, so I'm in Visual Studio Code. I have a completely blank file. So let's get into this. Let's obviously first define our function, write some test cases that we're going to expect to pass. Okay, so let's say we have a function and we want to call it, I don't know, merge intervals. That's what we're doing. That seems reasonable. And it's going to take an array of intervals, right? Okay, and let's put some test cases down. Let's say merge intervals. And this is just going to be straight from the slides. And here we are expecting this to return 1, 5. And 7 and 9, right? And I think I might, in the slides, I already had it sorted by start time, right? So if the start time would be the first element of the array, in this case, it would be 1, 2, 7. It's already sorted. I think I might switch it up just to show that this algorithm does work even when things are not in sorted order like we had them. Okay, and let's do console log merge intervals. And then we have, I think we only had one in the slides, so these are all going to be new. And for this one, we are expecting it to be 2, 4. That does not overlap with anything. And then we have 5, 9, because 5 and 9 completely overlap 6 and 7. And then we got one more. And this one we are expecting to return, let's see, so I think we are expecting 1 and 6, and actually we're just expecting 1 and 6 because 1 and 6 overwhelms 1 and 4. Well, 1 and 4 overlaps with 2 and 6, and it also overlaps with 3 and 5, and whatever, you guys get the point of this. Essentially 1 and 6 is the entire interval. And this is an important piece, right? We're not actually always just comparing two intervals. We have to merge all of them. And sometimes all of them reduce to just one interval because they all overlap in some way, which is why that stack data structure is going to be important, because we're not always just comparing the next two. We're actually always comparing whatever we saw previously, which might be the result of a different merge, to whatever we're going to see next. So you'll see how we do that in a second, but I do just want to call that out. Okay, so let's see here. So the first thing we have to do is sort the intervals, right? So let's do that really quickly here. Let's say const sorted intervals are going to be the array.sort. And I'm going to rename this because we know that this is intervals. Okay, so we have an array.sort, we get an A and a B. And here we can just return the A at 0, which is again, right? A at 0 is the start time, right? B at 0 is also the start time, right? This is A's start time, and this is B's start time, whereas A of the first index is going to be A's end time, and B at the first index is also going to be B's end time. So I just want to make that clear here. Often with these problems, you'll get objects and it will have properties, .start and .end. This particular problem, I'm doing it with arrays, but again, try and see past that. Okay, so we're going to return that start minus B start, and that should give us our sorted intervals. So I don't know, why don't we just look at that while we're going? I never do that when we code, so let's console log some things. Okay, so sorted intervals. Okay, so we can see here we have 1, 4, 2, 5, 7, 9 sorted by start time. We have 2, 4, 5, 9, 6, 7 sorted by start time, and finally the last one was already sorted, right? Okay, that's wonderful. And now what are we going to do? So now we have our sorted intervals and we can initialize our stack. And what are we going to initialize our stack at? Because we haven't gotten any intervals yet. So that means we have no A to compare B to, B being that first interval. So what we can do is I don't know if this is a good use of the word greedy in an algorithm context, but I'm going to go with it. You guys can correct me. I'm not afraid of you. So we can greedily take that first interval and call it A, because that's the best we have so far, and we can always work from there. Because the first interval will be the earliest start time because it's sorted, and we can either add or merge to that interval as we go. So let's say we're going to have our const merged intervals, and this is going to be the sorted intervals dot shift. It's going to be whatever is first in that interval. And shift will actually remove that element from the array. So we're going to slowly take away from those sorted intervals until there are none left. And that's when we're going to know that we've already merged all of our intervals. We've taken them all into account. So we can start a while loop here, and we're basically just going to go through this array while there's still stuff to be merged. So what does that come out to be? While the sorted intervals has length, right? That means that we still have intervals to merge. So let's define some things, right? So we always want to compare, I'm just going to write this down, the last interval seen, which will be merged intervals, which will be the last element in the merged intervals stack, right? Because that's how we're going to be using it, to the next available interval in the sorted array. So what does that mean? So basically, we're going to define our A and B here, right? These are going to be the two intervals that we're comparing. So A is going to be, what is A going to be? It's going to be merged intervals dot pop, right? So we're using this as a stack. We're going to take it off the stack. We're going to deal with it. And we may put it back on the stack, right? Depending on the different rules. But we may not, because we might have a totally new interval that we want to put instead of it on the stack. Just because it's on the stack doesn't mean it's staying there. And that's the whole beauty of this problem, is that we're merging things. And I always like to think this more as a reduce, right? We're reducing an entire array rather than like adding to it. This is kind of a reduction here. We're merging things. Anyway, I hope that makes sense. So that's A. So what's B? So B is going to be the next thing in our sorted intervals array. And we want the first thing on that because that's in order, and we want the next possible thing, which is going to be the first thing. It's the earliest start time in that sorted intervals array. Okay, so we shift off of that. We've modified both of those arrays, right? The pop and the shift take things out of the array. And now we're going to do kind of our scenarios. So what are our possible scenarios? We have A and B don't overlap, right? So that means we need both of them. So what do we do then? Or what does that kind of look like with A and B? So we can say that and actually before we do that, let's also pull out the B dot start and the A dot start, B dot start, A dot end, B dot end. So we can do ES6 destructuring here, which is kind of nice. So we can say that const A start and B start, A start and A end is going to be equal to A, because A is going to be, right, just an array of 2. So that means A start will be first and A end will be second. So that's destructuring for you. And then we can do the same thing with B, right? B start, B end equals B. So what are our scenarios here? If B start is greater than A end, meaning they don't overlap at all, right? Because B starts after A ends. We need both of them, right? So what do we do here? We're going to push both of those onto our merge interval stack, which does mean that we took A off and now we're putting it back on, but we're also going to put B on that stack. And then B is going to be our next A for our next iteration of this while loop. So we can say that merged intervals dot push, we're going to push A, and then we're going to push B. And that's very easy. And now here we're going to say, right, all of our other conditions here. Else, they overlap. So we have to merge in some way, right? So here we're going to be merging. So what do we always do, right? When we're merging, we're going to take two intervals, A and B, and we're going to return a new interval, C. So we can define that, right? Const C, it's going to be an array. And we already know that it's going to have C dot start, right? C start is going to be A start, because A start and B start are either, A start is either earlier or the same as B start. So it doesn't really matter, right? So we can say C at 0, which is the start time, is now going to be A start. Okay, wonderful. So we have our new interval start time. So what about that end time, right? So what are we going to do? We are going to take the max of the two intervals end times. And that's very simple and straightforward here. So let me scroll down a little bit. We're just going to take the math.max of A end and B end. And whichever is later will be the end of our interval. And then we just push it onto that last, onto our stack. So C is going to become our next iteration's A, if that makes sense. And I think that's the whole algorithm. Again, this is very bare bones. This is the most simple it gets when it comes to merge intervals. So after that while loop, I think we can just return merged intervals. And let's see what we get here. Okay. So, all right, so we have 1, 5, 7, 9, that's correct. We have 2, 4, 5, and 9, also correct. And we have 1 and 6, it's also correct. Okay, so we set out what we did what we set out to do. I think the difficult piece of this problem is not necessarily those scenarios. It has nothing to do with those merges. It mostly has to do with understanding how to reason about the intervals, how to kind of go through them using a stack so that you can continuously be modifying the interval you just created by comparing the two previous, if that makes any sense. I think that's where people get tripped up with this sort of thing. This part is actually extraordinarily simple and easy to understand. And especially if you break it down visually into those scenarios, it kind of becomes obvious. It's like, oh, duh, you take the A start and the bigger of the two ends. So that's the thing I think that everyone should really practice and understand here. And then we're basically just going to continue to make it, slightly harder, increasingly harder in the next few videos. But yeah, hope you enjoyed. And that's it, everybody. Happy first day of merge intervals. I hope you all enjoyed that. We're going to have 2 more coming down the road, all about merge intervals, a little bit harder, raise the stakes a little bit. And yeah, keep practicing and keep going outside because the weather's getting nice, at least where I live. And I hope everyone does things outside of coding. That is my greatest advice to you all. Have a good one, everyone. See you soon. Bye.